The name MineRL comes from combining the mine in Minecraft with RL, short for reinforcement learning, the type of machine learning devoted to creating agents that can learn how to act through observation and feedback. MineRL is a research effort to train autonomous agents, or bots, to play Minecraft. But what does it mean for a bot to play Minecraft? There are so many possibilities for things you can actually do, like play through the story in survival mode, build structures in towns, explore the world, and play with, or against, other players. Each one of these, let alone all of them together, requires an amount of sophistication and game knowledge that today's reinforcement learning agents just don't come close to obtaining. The reason for this is how these bots interact with the game. Take pathfinding, for example. In Mineflayer, a popular Minecraft bot builder, creating a bot to follow a player requires just a few lines of code, as it can use all kinds of information not directly available to human players, such as the current world coordinates of itself and the target player, whether it can see them or not. With all that extra information, you can use off-the-shelf pathfinding and behavioral algorithms just as if your bot was an NPC in the game being designed by a game designer. The goal of MineRL, on the other hand, is to have a bot learn how to play the game with the same inputs a human has, namely just the pixels on the screen. This is because the primary goal of agent-based learning is not so much to achieve a specific bot behavior, but to demonstrate how good the learning strategy itself is at achieving that behavior. Put another way, a successful outcome of a bot builder is to achieve some narrowly defined behavior within Minecraft, whereas MineRL hopes to use Minecraft and its dynamic environment and capabilities as a means to get closer to artificial general intelligence. MineRL uses a special modded version of Minecraft called Malmo, a package created by Microsoft Research specifically for general-purpose experimentation around agent-based learning. At every gameplay frame, a MineRL agent is provided with a reduced version of the gameplay screen, just 64 by 64 color pixels, and the contents of its inventory. It then must issue a game action such as player movement, camera movement, attack, jump, hold an item, or craft an item, for instance. In the event it does something good toward solving a particular task, such as attempting to chop down trees, it will also receive a reward signal, a sort of positive feedback that it can use to strengthen its memory to try to do that again in the future. Likewise, it could get negative signals to stay away from those actions if it encountered them again. As a starting point, MineRL has focused on a few well-defined tasks to learn, such as collecting wood by chopping down trees, navigating toward a beacon, and the Diamond Challenge. Train a bot to obtain a diamond, a key mineral needed to progress in the game. The bot must be able to do these from a random starting location in a randomly generated world. This means the bot must learn the game mechanics and goals, not just memorize a walkthrough for a fixed environment. As the exploration and crafting hierarchy knowledge needed to obtain a single diamond is large, however, this task is still quite difficult. One reason that reinforcement learning agents have a hard time here is that they start off knowing nothing at all about anything. They are just given a strategy for how to learn the game by the researcher. By the time you play Minecraft for the first time, however, you already have the entire experience of life up until that point to help you know that the screen you are looking at has terrain with trees, hills, water, animals, enemies, and so on. You may also know how to interact with the controls from previous gaming experience and have a good sense for what to do and try. You may even have read instructions or watched videos of other people playing Minecraft to learn how to do certain things. A key aspect of MineRL focuses on this last point. Is it possible for an agent to use these sorts of demonstrations and instructions and videos as a way to help jumpstart its capabilities. This idea is called imitation learning and is another key part of the MineRL project. A dataset of millions of gameplay frames captured from humans playing Minecraft to do the same task the bot is asked to do, namely, obtain diamonds. In addition to this dataset, MineRL provides tools for loading and processing this data and a way to play back the episodes to aid in other research efforts. Okay, great. So you're excited about MineRL and can't wait to jump in and start training agents to solve Minecraft tasks like deforestation. We won't go into depth on installation or training agents in this video. There'll be plenty more videos to go over each of those things later, but you can check out the MineRL website at mineRL.io. All the MineRL tools and documentation can be found there, along with instructions on how to download the demonstration dataset and announcements regarding MineRL-related competitions and package enhancements. There is also an active Discord server with the invitation link on the website and also in the video description. The MineRL tools are open source and written in the Python programming language, so to use them, you will need to be familiar with Python programming and its package ecosystem. You may be wondering if you need to have your own copy of Minekraft to use MineRL, and it turns out you don't. When you install the MineRL Python package, it will bring Malmo with it, that modded Java version of Minecraft used for research. Now, to be clear, this will not give you a free copy of Minecraft to play with others. It is really just geared and limited toward these sorts of research tasks. Finally, MineRL is a volunteer effort actively maintained by members from both academia and industry, with support provided by Carnegie Mellon University, Microsoft Research, and OpenAI.